Alright, so this should be recording here of the 2012 AB Multiple Choice Solutions, one of your first assignments here. And so I'm just going to go through and talk through a few that people had questions on. A number of people had questions, 6 people had questions on number 9. So I'm putting the solutions on like this because there's kind of some copyright issues with me showing the test, and so I'm just showing you the solutions here. And so with number 9, what we're looking at is one of those classic problems where you have a piecewise function and one of the problems has a k in it, and you have to solve for k that makes the function continuous at x equals 2. And so the whole thing here is to remember that if f is going to be continuous, then we can cancel out common factors and then have the value of the function and the limits from the left and right equal each other. And so you can cancel out those x minus 2's and just set 2x plus 1 equal to k and solve for k. Should, after that reminder, should be fairly simple. But if not, and you need more, just let me know. One person asked about number 11. Remember that with number 11, you've got absolute values involved. If you graphed that or think about what the graph would look like, you would know that you'd have what you normally have with absolute value, and you'd have like a corner or a sharp turn occur. And so that would make the function continuous but not differentiable where that corner occurs at x equals 2. The next one that we should get to is probably 15. 11 people asked for help on number 15. I've seen this type of question quite often. This is the one where you're given h of x is an integral of f of t, and then you're basically asked about what's greater than what or what's less than what with as far as like h prime and h double prime at the value of 6 in this case. And so first recognizing h prime is f and h double prime is f prime, and we would know that h of 6 is going to equal the integral from 0 to 6 of f of t, and with that, hopefully you realize that graph of f is shown right above the problem, and with the area under the curve for the entire interval from 0 to 6, we know that the integral value would be less than 0, and then h prime of 6 would be f of 6, and you can take that right from the graph that is exactly 0, and then h double prime would be f prime of 6, and f prime would be the slope at that value of 6 of the graph that you can see, and since f is increasing at 6, the slope is positive, and so then we would know a would need to be the answer where h of 6 would be negative, h prime of 6 would be 0, and h double prime of 6 would be positive. So that would get us our value for 15. 17, we had 4 people asking about that one. For 17, we have, I'll mark these so you know where I'm at, and if you wanted to fast forward when I get to them here. So for 17, you're looking at which of the following could be the graph of y equals g of x. And so for that one, f is the integral of g, so f prime is g. Since f is linear with a positive slope, g is a positive constant. I'm not sure what else to say about that. That's just the way it works. So that's what you would look for in the options shown. Number 19, 5 people asked for help on number 19 here. So with that one, you have that function, and you're looking for what points on the graph the property of the line tangent has a slope of 1/2, and so you'd take f, find the derivative using the quotient rule, simplify, set that equal to 1/2, and solve, and that gave you your value of c. 21 had a couple of people that were still asking about that. So for 421, you're basically checking the end behavior of each one. A sinusoidal function for A would divided by x as x approaches infinity, that would go to 0. Sinusoidal will bounce back and forth, but having an infinitely large denominator is gonna overpower that. There would not be a horizontal asymptote for the linear function b. For c, again, you're dividing by an infinitely large number, and so that's going to approach 0. D, you've got a rational function with the same degree on top and bottom, so you take the ratio of leading coefficients. 5 over negative 1 is negative 5. And then finally, the last one, you do the same deal, and you get 20 divided by 4 for your ratio leading coefficients, and that would equal 5. From there, we had 4 people asking about number 23. Oh no, we didn't. Nobody asked about 23. A couple people asked about 25. So with 25, that's an initial value problem. So you integrate 2 sine x, you get negative 2 cosine x plus c. You're given that y of pi equals 1. And so you plug a 1 in for y, a pi in for x, solve for c, and you get your solution, letter E. Let's see, so then I think I can go to the next page. So that'll put us here. There we go. Wow, 27 was a big one. 27 had 12 students asking how to do that. So that was one where you were given this equation with x's and y's and a dy dx, and you're asked to find that second derivative. And so on this one, you got to implicitly differentiate. So when you implicitly differentiate, you're looking at the product rule here. So the derivative of y prime would be y double prime. Leave the first part alone. Leave the y prime alone and take the derivative of x plus 2y. That's what's there. And then from there, on the right side, you implicitly differentiate as well. And then what you can do is you can just plug in your 0.30, and I plug that into first the original statement given to solve for what y prime would be at that point, so that I could then go back and take the derivative that I took, or when I implicitly differentiate, I could plug in a 2 for y prime, and I could plug in a 3 for x and a 0 for y, and then just solve for y double prime to get that negative 10/3. So that was definitely a little bit more time consuming than many of the problems. So that was a good one to be asking about. 29, I had one person asking about, since f prime is positive, f is increasing, f prime is increasing, then f is going to be concave up. So that got us that answer of E there, where that's going to be true. And then if we go on, 31 also had 9 people asking about number 31. Not sure if people noticed, but once we're on 31 now, so calculators are allowed. We were looking for when that crosses the x-axis, and so I just set that equal to 0 and solve, and then I'd plug that into the derivative, or I would just take the derivative at that point, use the numerical derivative function on my calculator to get that answer that we needed there. 33, 3 people were asking about 33. As you can see, I made a sign chart. I is true because of relative minimum deal going on there. Minimum at x equals negative 3 is probably what that should say right there, because we went from, our f prime went from negative to positive, and then looked at the second derivative going from positive to negative at 0, so 2 would be false and 3 would be true. So I can't remember if I just mentioned this or not. I got a phone call from somebody at work when I was making this. So, but step 3, that would be true because f double prime would be negative, so concave down. from 0 to 4. 35 had 3 people asking about that. F has a local max where f prime is going to change from positive to negative. Just looked at the graph and saw that was at x equals 0.35. Again, these would be a lot harder if you didn't realize or recognize that statement saying you could use your calculator at this point. So from there, 37 had 7 people that were asking for help on that. So that one's asking about concave down. If you're given the graph of f prime, f is going to be concave down where f double prime is negative, which is going to be where f prime is decreasing. And again, looking at the graph, if you graph that function, looking at the graph, you'd be able to find the intervals where f prime is decreasing. So that's all I did on that one. 39, we had 9 people needing help on 39. For this one, we know f prime is greater than 0, and we know that the integral from 4 to 7 is 0, integral of f of t. And so then I would be looking at, since f prime is greater than 0, f is increasing, so c and d would be crossed out. Integral from 4 to 7 is 0. That means that the graph's going to have, part below the graph, part above the graph, and b would be the only one that would fit that option of what remains. 41 had a lot of people. 16 were asking about that. I already made a video on 41 that's on Google Classroom, so you can take a look at that using the related rates proportional triangles, setting up a proportion on that one. 43 had 3 people looking at questions for that. Personally, I think that 43 is one of the harder ones for people to understand. You have to kind of remember how functions work and when you manipulate different parts. So what I would say is, what I wrote down is f of 2x is a horizontal shrink by a factor of 2 of f of x. And so the integral from 12 to 24 of f of t would be the same height, but twice the width. And so then the integral from 12 to 24 of f of t dt would be 20 because of that. So hopefully that helps you with it. If you need more on 43, I can write something else up. Just let me know. And then 45, we had 8 people asking for that one. That's one of the newer topics. Again, won't be on the AP exam this year, but certainly something you should know and is usually challenging for people. So this is where you got squares coming out of the page. So the cross sections are squares. So the area of a square is a side length squared, and the function that we were given, or the area that we're given is formed by x squared minus the square root of x minus x squared. And so that difference would give me the length of a side of the square, so I'd integrate that squared from 0 to 1 to get my answer. Okay, on to the second half. It looks like we had nobody asking about 2, nobody asking about 4, one person asked about 6. So the biggest thing for total distance, you do have to consider where your velocity is negative. In this case, though, on the interval in question, the velocity is always positive, so you can just straight up integrate from 0 to 3. Otherwise, you'd have to split up your integral and take the absolute value of the portion that would be below the axis of the velocity function. But that didn't happen here, so you're all good. Number 8 had 6 people asked. So this one asks you to use a right Riemann sum with 3 subintervals. That's a right RAM. So you just had to remember to take the initial amount that you had was that 50, and then integrate from 4 to 15 using 3 subintervals. So that's going to be 3. The space from 4 to 7, that distance is 3. That's why I'm taking 3 times 6.2. And then from 7 to 12 is 5. That's why I'm taking 5 times 5.9. And then again, the distance from 12 to 15 is 3. That's why I'm taking 3 times 5 on that one. So that's a right RAM on that one. 10 had 5 people that wanted help with number 10. That's find the area of the region in the first quadrant, bounded by y equals e to the x over 2 and the line x equals 2. And so for that one, basically just integrating from 0 to 2 because of that x equals 2, and then basically just use a u sub integrating that function, unless you just know what that is. You don't have to use u sub, but a lot of people would use u sub where x over 2 would be your u value, so that you get that appropriate 2 times 1/2 out front. So from there, again, with any of these, if you need more, just shoot me an email and I'll give you more. Just trying to go through it quickly. We're already at 15 minutes. Just going through 45 problems does take a little bit of time. So number 12 then had 5 people asking about that. With that one, we were looking at it actually told us to use a u sub and told us what the u value should be. And that was one of those tricky ones where you'd need to plug back in. Actually, you wouldn't have to plug back in, but changing the bounds, that's where people kind of mess that up. But I've got my work there. Let me know if you need more than just that work shown. 14 had 5 people asking about that as well. Kind of looking at the derivative of a composition, so you could have plugged the 3x minus 2 into the x through the x squared and simplified like I did, and then just differentiate, make sure you use the chain rule and plug in. From there, 16 was a big one. That had 9 people. So ultimately we're asked, when's the particle at rest? And so that would be looking at when is the derivative of the position function equal to 0. So I would expand the t minus a, t minus b, take the derivative, set equal to 0, and then find that t would need to equal a plus b over 2 to get to be at rest. Let's see, 18 had 6 people asking about it. Ones like this, when you see that limit with h's and you have that quotient, hopefully you're thinking, well, how does this look like the definition of a derivative? And it was basically asking what's the derivative of the natural log of x when x equals 4, and so that's where I went. You could use L'Hopital's rule to get to that solution fairly easily as well, but recognizing the definition of derivative would be great. I'd like to have thought you'd do that. Number 20 had 3 people asking about it. That's that inverse relation. So for that one, we needed to solve for the derivative of f. When I take f prime of 0, I get 6. And so again, since f of 0 equaled 1, then I knew that g prime of 1 would equal 1 over f prime of 0. And so then that would be that 1 over 6. On 22, we're looking for absolute maximum. And so take the derivative, set equal to 0, and looking for a change in sign from positive to negative. And so that happened at x equaled e. And then we plug that e into f because it asks what's the maximum value. What is the actual maximum value? That's not the x value, that's the actual value of the function. 3 people wanted that one. 24, we got 6 people wanting help on 24. That one is a little bit more unique. You're given a function g, and within g there's a constant k. Looking for what value of k does g have a critical point at x equals 2/3. And so then for that, I would need to use my product rule to find g prime, and then critical point is going to occur when I have that g prime equal to 0, or where g prime would not exist. And so that would just be when I would get kx plus 2 equal to 0. And so that would be at x equals 2/3, I believe. I wrote there, hard to see. So plug that back in, and I get a k equals negative 3. Alright, we were given that x would need to equal 2/3, and then you just solve for what k would need to equal then for that to work out. 26, looks like we had 5 people that were looking for help on 26. And so you're given g prime is the integral of some function here, which of the following must be true on the interval from 0 to 2. So since the function that we were integrating is greater than 0 always, then g prime, which is the integral of that function, is going to be greater than 0. So that means g is going to be increasing, and g double prime is going to equal that inner function, which is also greater than 0. So g is going to be concave up for A. Looks like 28 didn't have anybody looking for help. 30 had 2. 30 you need intermediate value theorem to help you on that. So what I just said that D is also true, but by the mean value theorem instead of IVT. So A is IVT basically, saying what IVT is. 32, we had 6 people looking for help. That average value, that's looking at, integrating velocity from 0 to 8 and then dividing by 8 minus 0. That would be the same as that change in position over change in time. So that was 32. 34 had 8 people asking about it. Now, again, we are into the calculator allowed bit of this assignment, so recognizing that would help you out a lot, I'm sure. So 34, you're looking at, make sure you have that initial value to find the amount pumped. So you'd start with 800 gallons, and then you integrate from 0 to 20 your rate function to get how much you ended up with at 20. T equals 20. 36, nobody was asking about 36. 38, we had 1 person asking, and so local max is going to occur when f prime changes from positive to negative. And so on that one you were given a graph. Hopefully you notice the graph above the problem, as it said in the problem, and since f prime changed from positive to negative, we knew that answer. So 40, it looks like nobody was asking about 40. 42, we had a lot of people. We had 9 people asking about 42. So this one was a little more unique too. We were given the acceleration function, and we were given the velocity at t equals 0 is 5. So again, since we get to use our calculators, if we want to know the velocity at t equals 3, I just take my velocity at 0 and I add to that the integral from 0 to 3 of my acceleration function, and that will give me my velocity at t equals 3. So I like that problem. That's a nice problem. And then 44 just had 1 person asking about that one. F prime switches from increasing to decreasing to increasing on the interval. F double prime switches from positive to positive. So F has 2 points of inflection. Thanks. Sorry that was so long, but hopefully it answered all your questions. If not, email me.